Docklord is a lightweight, high-performance Docker container management and monitoring tool written in Rust. It acts as a proxy-like orchestration bridge between clients and Docker hosts. You don't have to deploy your own coordinator. You can use my pre-configured coordinator, which I'm showing in this video. However, for this demo, I'll show how to set up your own coordinator and node from scratch, and we'll make requests from a completely separate device to control containers remotely in real time. First, I'm logging into my remote server. Before launching the coordinator, I want to make sure that the required ports are open and accessible. Since I'm using UFW as my firewall, I can check the current status by running UFW status. Here, I'm specifically looking for port 50051 for gRPC and port 3000 for the REST API. If these ports are blocked, nodes or clients won't be able to connect. Once I've confirmed the ports are accessible, I'll make sure I'm using the latest version of Docklord. I just run git pull. Now, I'm ready to start the Docklord coordinator. I can run it using Docker. Docker compose up Docklord coordinator. Or, if you prefer, you can run the binary directly. Now that the coordinator is up and running, I'll move to my local device to start a Docklord node. The node is the agent that connects out to the coordinator and executes Docker commands locally. I'll run the node using Docker, specifying the coordinator's address. For example, if my public server's IP address is 82.27.2230, I run coordinator utter equals http://82.27.230.50,051 Docker compose up Docklord node. Once the node connects to the coordinator, it will display the noded and password in the console. It's important to remember these credentials because every API call from a client must include them to authenticate and control containers. At this point, we could verify the node's functionality locally using a simple curl request to list containers. However, in this demo, I want to show the real power of Docklord, controlling containers from a completely separate device without even having Docker installed on it. Right now, we'll start a PostgreSQL container on this device with active node, and then we'll monitor its status from another device using the noded and password we obtained here. Now that our node is running and connected to the coordinator, I'll demonstrate how to monitor and control containers using a WebSocket connection. First, I open a WebSocket client and connect to the coordinator's API endpoint. I provide the noded and password that we received when the node started. This authenticates my session and allows me to receive real-time updates from the node. Once connected, I can see a live list of containers on that node. At the moment, no PostgreSQL container is running. Now, I'll start a PostgreSQL container on the node device. As soon as it starts, it appears in the WebSocket feed. We can see the container with the name PG. Next, I'll take the PG container and send a stop command through the API. The WebSocket immediately reflects the status change, and we can watch the container shutting down in real time. Finally, I perform a GET request to list all containers on the node. In the response, we can see that the PG container is now in the exited state, confirming that the stop command worked correctly. This demonstrates how Docklord allows full remote control and real-time monitoring of containers, all without needing Docker installed on the client device. For more detailed instructions and configuration options, check the README, MD in the repository. Thank you for watching.